Welcome after the break. I would like to introduce Gis, who's going to talk about security features of modern Android. And if you have any questions, please raise your hand and I'll bring you the microphone. Thank you.
Thanks very much. And thanks to Confidence for inviting me out. It's wonderful to be here. It's been a really fun conference. And I'm Jesse Burns. I'm from a company in San Francisco called ISEC Partners. And I've been doing Android stuff for a while. In fact, I've even spoken at Confidence on Android before. But the talk that's listed on the schedule is not technically the talk I'm giving today. I'm giving something a little newer. It's on a really exciting set of functionality that's been introduced with Android Jelly Bean, the multi-user mode. And it's, anytime something goes multi-user, it's a real big security target. So it's something that I hope we'll get to play with and will eventually give us more power on mobile platforms. So I've previously presented a talk here called Exploratory Android Surgery. That was in 2009 in Warsaw. In the years since then, actually, Android's advanced a really long way, not just in terms of its actual technical improvements, but also in terms of its adoption. It's now super popular, the leading mobile smartphone platform. And its security has gotten a lot of attention, although we haven't actually seen too much malware yet. So it's exciting. So here's what I'm going to go over. I'm going to talk a little bit about that security evolution that Android's gone through and about its most recent version, Jelly Bean. And I also want to discuss sort of what the idea of multi-user security is and help you understand how it works and what it can do for you, what you might need to be thinking about if you're implementing features on Android devices, especially if you're trying to implement security features, custom Android distributions, mobile device management stuff, or anything that's going to be running as part of the system or system services, and also just to understand the safety of those devices and the security models for them in your enterprise. So if you're going to have BYOD devices, what this might mean for that, hopefully. So it's not super straightforward what all the security promises are, so I'll kind of talk a bit about that, and then I'll get into what they are and how they're implemented. If you haven't seen my earlier talk on Android exploratory surgery, there's a bunch of Android IPC stuff that's involved here, so I hope that you're somewhat familiar with that. Please feel free to ask questions if you get confused about anything. All right, so Jelly Bean and its features. Android has this really weird naming scheme. New versions, like when they go from version 1 to version 2 of Android, you always get a name. But even when you go up a full dot release, you sometimes get a name. So minor numbers sometimes get one. Dot releases can actually occasionally get names, like the dot release even. So like Gingerbread 2.3 and 2.3.3, that's the same name, but it's a different API. This is sort of a weird setup. So they've got these three different things. They've got the name of the release, cupcake, jelly bean, ice cream sandwich. That's what people tend to use. Then they have a number, which is sort of random. And then they have an API number. And that API number is the best way for us to think about Android releases, because APIs are where they're going to change the semantics of the platform. They're not going to make a meaningful change in the semantics of your APIs unless they update that number, because they want you to be able to say, hey, this app works on this particular version. So if you see a bunch of major numbers go by on your phone, you should be worried that you're running software that's quite out of date, right? You can't have the latest version of Android and be running something like ice cream sandwich, which people think of as pretty recent, right? That was from October of 2011. And that's the first version that had the Linux kernel, the Linux 3.01 kernel in it. So that's a pretty long time ago in mobile time, right? We're on API version 17 now with the latest release of Jelly Bean, which just came out. So if you think each of those API numbers, you can kind of think, hey, that's a major release. And sometimes even in minor releases, like I'll talk about an example of a bug that was fixed in one of these minor releases. API releases can have, they will have security changes that are really big deals, and even minor ones can, of course. So you might remember that the most popular versions of Android are these gingerbread devices. That would be down in version numbers 9 and 10. Right? So we're on 17, and they increment monotonically. All right. So what's new in 17? Well, first thing is they didn't change the version name, right? Version 17, API 17 of Android is also called Jelly Bean. So is 4.1. So it's just Jelly Bean release 2, I guess. I don't know. Jelly Bean. So we got a ton of new security features and no new name, which makes it really confusing because when you pick up a device, people might say, oh, it's Jelly Bean, and they might mean the old Jelly Bean, not the new Jelly Bean, right? This is the one that doesn't have the multi-user mode. There's a lot of really cool new security features in this. Things like changing the way that permissions get displayed to users, not exporting content providers by default, which is a really big deal because content providers are basically SQL databases, and if you're storing information in them and you didn't protect them, you don't want just any other app to come in and tweak them. So of course, security conscious people have always been securing them. There's rich stuff for securing them. But if you don't know about it, you probably didn't bother setting any of that up, and so if you don't know about it now, it just marks it not exported by default, so that you have to actually know about it to open up the exposure, which will hopefully stop the slackers. Another really cool feature that they've added in 4.2 is ADB control. So if you ever looked at a device that's one of your developer devices and it's got ADB turned on and you leave it in a car or something, someone finds it, they can just plug in and pull stuff off and debug your device, and that's not as much fun. So now when you plug in a device with 4.2.2, it actually asks you, hey, is this the computer you wanted to be talking to? And it has like some cryptographic verification of the developer workstations it knows about. And that means that if you have a screen guard on there, they're going to have to get through that screen guard somehow. So if you're a developer who's doing this sort of thing and you want to test it with a screen lock on, no problem, but you lose it in a car and you've got some extra protection. So, and that's a great example of a security feature that was introduced in 4.2.2. So it wasn't in 4.2.1, right, which was released last year. It was in 4.2.2, released this spring, and that feature doesn't change the semantics, so it didn't need to change the API number. All right, so I gave you that big list of security features. That stuff in bold there is from their webpage, developerandroid.com, Jellybean, about versions Jellybean. And one thing it doesn't list is multi-user support. That page lists it and talks about it, but it doesn't call it a security feature. It's just a feature. This is for normal people, right? And this is, I think, the biggest new feature. It's multi-user support. It's only for tablets. So if you've got a phone, this isn't going to let you have multiple users on phones, and we can talk about why that is. But that'd be tricky, right? You would think maybe dialing and billing would be something that would be important to isolate, so multi-user might not be so good for that. Users have different names and passwords and data in this multi-user environment now, and they're going to be able to keep that stuff all isolated. There's this new concept of an owner, so the very first user that gets a tablet running Android 4.2 is going to be able to be the one who is kind of the true owner of it, and everyone else is a guest. And that's a completely new concept. In Android, right, when we've had users and stuff in the past, that's always sort of meant programs that are running on the device. And then there's also tons of new cool security things under the covers. One of the big things in Jellybean, and it actually came in 4.1, was isolated services, which provides a type of sandboxing support so that you can have services that do things, and if they get popped, like maybe the rendering engine has some bug in it and it gets exploited, it doesn't have the full permissions of the app, and in fact it can't do most of the things that an attacker would want to do. Another huge change that really didn't get much attention, just kind of slipped in, not at this year's Google I.O., but the one before that, when they released Jellybean, was they've gotten rid of read logs for most user applications. And this is the permission that let apps, like I would install these apps and they'd ask for read logs permission, and that lets them see anything that any of the other apps write in the logs, right? And that's like cool if you're iOS, but it's not a very like Android-y kind of thing. You don't want to have other people reading what you're writing there. It's often stuff about what programs people are using, what views they're on. Sometimes it's got roles and debug information, it can be a big mess. So that's been historically a big place for information leakage on Android, and by raising its protection level, they've kind of made it go away. So there's also this notion of SE Linux. It's kind of hard to see. I'm not going to talk about it much, but you kind of hear some buzz about it. If you find a way where that protects you, please let me know, because I'm always curious to see where people are actually getting any benefit from that. But it's not something that Google's featuring, but it is in the code. And then one of the other things that's kind of neat is they've deprecated at least this mode world readable and mode world writable flag that was used to mark your files as other read and other write. And you can imagine that in a multi-user system, that changes quite seriously what other read and write would mean. So that would be a big problem. So we're deprecating at least in API 17 that notion. All right, so what kind of isolation are we going to get with this multi-user? It probably won't be perfect, right? You have a limited amount of space. You're going to want to share apps. If you just did like a full system install for every user, that would blow out your tiny little bit of memory. So we have to just sort of look at the platform to see that. And it's actually not totally obvious. When you go and create a user on Jelly Bean, you get this warning. And strangely, you get this pop-up dialog that I've seen here, and you can get either one of these depending on the version, that says, hey, after you create this, the user that you create is going to be able to accept app permissions on behalf of all of the users. And so if they have some app that's installed, they're going to just be able to upgrade your app. And because they want to keep all of the file storage safe, they don't want to keep like two versions of Chrome, one where you didn't bother updating and one where you did. And sometimes when you update, you have to have new permissions, like maybe it wants to be able to access the phone state, reads phone state, or read contacts, or some weird thing like that. So that could be, that's like a hint of one place where stuff might leak. The other warning, which I thought was a lot scarier, was this: as with any computer, you should share this tablet only with people you trust. And this happened on my Nexus 7 when I fired it up. And it happened not when I created the user, but when I went in to set up the user, by which point, presumably, it's the user that's getting that message. But it kind of scared me. A lot of times, companies kind of hedge about what their security model is, and that sounded pretty hedgy, but it doesn't actually seem like it's burned into the platform. In fact, if you put on Android open source program build on a device, you don't necessarily see that warning. So. Some other places we can find tips is the documentation, and the documentation makes us much stronger claims, and that makes me feel a lot better about it. It actually says that the app's users is complete, or the app's users see completely separate devices. So that's a little bit hyperbolic, probably. I doubt that. But it then goes on to explain that there are basic limitations of that separation. So device identifiers like the Wi-Fi MAC and the serial number aren't per user, they're per device. So there's this dichotomy of things that are per device and things that are per user. And that's a complicated nest to unpick. And so that's part of what I'll try and talk about. All right, so which is it? I was a little confused when I first saw this. I thought maybe that this was a fake security boundary. Like if you look at how some other platforms have dealt with this stuff, like when you have the Apple Sandbox, they have these syscalls they have this syscall called Sandbox. And if you look in the man page, it has this warning that says, it is not a replacement for other operating system access controls, right? And you can go and look online and you can see that they use that syscall to implement their sandbox profiles. So surely the profiles must be a security boundary, right? The profiles clearly have some goal in mind that a user should be able to understand, like KSBX profile no network and KSBX profile no internet. But when core security researchers, I'm going to murder their names here, Annabelle Sacco and Matthias Esseler, bypass that protection. It's funny, they posted in their disclosure stuff, the kind of back and forth they had with Apple, And they said that the vendor informs that it does not see any actual security implications. The KSBX profile no network sandbox profile does not promise that Apple events will be blocked in the documentation. So specifically, it guarantees, all it guarantees is all socket-based networking is prohibited. Then Core responded that that network profile should guarantee that all socket-based networking is prohibited, and the POC sent to Apple shows that through the use of Apple events, they are able to get sockets. And then they responded that, currently we're considering modifying the documentation. So, that would be kind of the worst case, when you have a security thing that everyone thinks is a real thing, but vendors are backing away from it and not going to fix the bugs. And actually, they did eventually fix that in OS 10 version 10.8.4. So at least according to Core's vulnerability disclosure. Then I mentioned a few of the issues that I'd been noticing, and I got, a whole bunch of interest back from the developers or from the people who are patching this platform. And they were basically saying this is clearly part of their security model, and they're trying to make it solid. And it took me a little while before I noticed the fixes. Like I sent this email saying, hey, look at these things. And, nothing happened for a while, sort of. And then all of a sudden there was a release. And I went and looked at the new source code. And I saw that 2 days after I'd mentioned it to them, it had been patched in the code. And that's exactly what you want to see. Now, it takes a long time for those patches to propagate. So it'll probably take, a lot of people aren't even on 4.2, let alone on 4.2.2. Because 4.2.1 was the first version of the 4.2 chain. But, it's definitely something they're trying to build. So guests are going to have to trust owners. The people who use the tablet are going to have to trust the tablet's owner. But owners are going to be trusting guests less. We're going to try and make this secure so that if you give your tablet to someone, they can't just take it and read off your contacts or read off some other guest's contacts. But the owner, they could have rooted it. It might not be a tablet. It might be a PC that's like secretly behind a piece of glass and it looks like it's on the table, right? They're the owner. They can do anything. They could have like a camera over your shoulder. That's sort of the trust model. You're going to have an attempt to stop the guests. So how are we going to do that? Well, one of the big things that changes, sort of the most obvious thing, is that process and UID model. So Android has historically used UIDs to isolate its apps, and now that UID thing is the thing Unix used to use for isolating users. That's already been used. So they're going to have to do something else, and what they've done is they've built on that. I'll talk about that a bit. There's this whole system of activities, broadcasts, intents, receivers, content providers, all this stuff that I call Activity Manager Arbitrated IPC. This is all the IPC that you don't read about in advanced programming in the Unix environment, but you do read about in the Android documentation, right? Stuff with binders, stuff with services. Anything that uses Android permissions and goes through the main system. Obviously, that has to change a lot in order to put this kind of protection in place. And so in conjunction with that, there's a bunch of new permissions and API parameters, or basically new APIs. And then there's also some storage spaces for apps. And also, even cooler, some use of Linux namespaces to do isolation for external storage. So I don't think there's any SD card devices running 4.2 yet. Maybe I'm wrong, but I haven't seen any. There's this notion of external storage, and historically it's been a giant hole on Android. People have shared this one kind of global space, and that means apps could read and write stuff, and they're trying to address that. The other big new security concern here is the idea of owners, and there's also a change to the way system settings work to allow those to be more isolated per user and less kind of device-wide. All right. What isn't protected? So anything that's device-wide can't be totally protected. So that's probably why this is tablets only, right? You've got your messaging and calling on phones. That's a pretty reasonable function. You don't want someone sending toll SMSs if they're just a guest. Maybe that'll come someday, but it's not there yet. The idea of the system logs, So now that read logs permission isn't something that can be granted to apps, you don't have to worry that a user is going to just install an app that has read logs, because those things have to be digitally signed by the same key that built the system. But you do still have those system logs mixing together all the data from the various apps. So it's something that's there. It's device-wide still. And if you had some app that somehow disclosed that information, maybe by sending bug reports or something, you could imagine a low-rights user gaining access to it. Shared system service state. So there's things like the system services, activity manager, the clipboard, location manager, all these things that run in the background. They're all device-wide, always running things. You don't want to duplicate that code for every running user, or you'd load up the system. It already uses way too much memory. That's a big concern. So you have to change those things, and I'll show you how some of those changes work. And then shared system settings that aren't migrated. So there's things, configurations like Wi-Fi. Wi-Fi is too important to just not allow people to use, right? We need to have that sort of be trusted. Also, normally when we think about Android devices, anyone who's touching the screen outside the lock screen is trusted, right? They're the person who bought the device, and they're the ones that own it. And now that assumption isn't true. So if you're building like an MDM product or something that has a trusted UI, you have to start thinking about, hey, is this something I should only be exposing to owners, or something that I should be exposing to all users? Because that's a pretty fundamental change. Oh, and then, yes, of course, guests aren't protected from owners. All right, so UIDs. So Android apps have always had their own UIDs. When you install some app, it doesn't get the same UID it got on my phone. It gets one that's for your phone that was free. And that's just the way it's always been. I talk about that a bunch in my other talks. And each app on a device can now run with multiple user IDs. So with 3 users, you could have 3 copies of the launcher, and I don't have 3 copies of the launcher there, but the first column here is the user, and you can see that this COM Android launcher, one of them is running as U10, A18, so that's user 10, application 18, and one's running as U14, A18, so that's the same COM Android launcher running as a different user, right? 2 different UIDs. So they've partitioned this space. And you can see this in a bunch of different places in the code, including in the Android file system config in this stubs file. But the gist is that they're taking this big 32-bit space that they had for UIDs, and they're just breaking it into ranges. So there's this user range, and they kind of multiply it by a user ID and add on the app ID. And then they have a way of sort of saying, hey, given a UID, compute what the user is, compute what the app is. And they can use that for the UID and the GID, and when they store files or data on the disk or on the flash, they can use that for isolation. And they can give a totally isolated environment to each application, but have them share all the binaries and copy on write for all the apps. So even when you've got 3 copies of Launcher running, it's not very many more pages of memory. Let's see. There's also, I mentioned this new isolation thing that showed up. And this is a really cool feature where you can have apps that run isolated. And that means they just get IDs in a range that's like 999. 000 to 99999, something like that. But it's just a special user space for things that are not going to be privileged, and so they won't have any they won't have any. Oh, and here I've got them written down, so that's correct. It's really easy to use this new service isolation. All you do is when you build a service, you go in and you mark it as isolated, and that'll make it so that its UID kind of magically picks up one of these isolated range UIDs, and you're not going to have to be as concerned about that process inheriting your super high privilege rights. So especially if you've got something that, like an app that does something really risky, like renders a bunch of rich media content with weirdo codecs and has access to the contacts this will let you keep that safe. You're going to still obviously have some rights, but you won't even have access to the network or other things that come in automatically through the normal Android permissions. And actually, the Activity Manager also has special support to do things like blocking starting of activities from these isolates. So if you look now, there's there's functions in there that check to make sure that callers of a lot of pieces of Activity Manager verify that those callers aren't isolated before they're allowed to run. All right. So service isolation. There's another concept here. So we've got 3 UIDs, 3 GIDs for our example launcher. It's on a system with 3 users. There's also a special group ID, which is this all A18. So that's 50018. And that all kind of disconcerts me a little bit. It's the idea of a group that's shared by all the apps that run as a particular application, right? Or all the user IDs, like all the apps share that one GID. It's not the primary GID, it's just a secondary, but that could still potentially let you have access to files and other things. And it doesn't seem to be that useful. So how do we actually manage this or these new permissions in the Android Activity Manager? There's a lot of stuff that is only sort of documented in here. So if you read the source code, you can see how it really works. And the source code is very friendly, commented, and has meaningful discussions about feature changes in the history and commit logs. So that includes a lot of things like that are at hide, so you can't actually see them when you look in the normal system API docs. But they're still sort of explained, and they'll even explain sometimes why they don't like this or why they haven't exposed it. And one of the things that has been added is a bunch of new permissions. These permissions are signature permissions or higher, so they're more dangerous than dangerous. And that means that you can't generally just grant them to apps that you install on the device. The device has to have those apps specially signed. And one thing that's really important about these from a security perspective is that the shell has almost all of these, except for the access all external storage right. And that means that the ADB user that you're going to be shelling in as when you're doing development, it's going to be able to do this interaction across users and let you sort of see what's going on across users. So briefly, what these permissions do is the interact ones let you send broadcasts, start activities, do whatever you want sort of through Activity Manager between the user IDs. So if you're going to be talking from one to another or switching or accessing someone else's, sending a broadcast, starting an activity, that's what you're going to use. The access content providers externally is, actually I'm not going to get into that one. The manage users one lets you create and list users, and there's a lot of commands that if you run them in the terminal and you don't have that, they'll just fail. So if you go like PM list users, you'll get a fail until you do it as ADB shell, and then all of a sudden you'll get your list of users. All right. Here are some of those APIs that have been introduced. So we've got this send broadcast as user, and you can see now it's taking user handles. And so this is letting you do the cross-user registration with the register receiver, so you can register your own receivers. And you're going to have your interact across users permission to use all of these things. The docs for these methods are making this kind of weird claim that this is not available to applications that are not pre-installed on the system image. That's actually not right. Actually, anything signed with the system key could get this permission, as interact across users has the protection level of signature, right? So anyone with that signature is going to be able to do that, which means that if you've got some OEM that's made your device, they could release a third-party tool, or sorry, they could release a tool later that interacted with any of these things. So you do still have to be kind of careful about installing new stuff. So basically every Activity Manager mitigated IPC system has a user isolation API that's been added to cross it. And those just get protected with these permissions. All right, so how does this look on the file system? So normally you have your user data partition mounted under /data, and all your apps go under there, right? And you see like data, com.foo.bar.quux, files, whatever, right? There's some new stuff now where we have this directory data users, and the 0th user, the owner user, is just in data, right? But under there, and they number their users kind of funny, right? The users are 0, 1, 0, 1, 1, 1, 2, right? So it's sort of this funny numbering system for users. But they all have a directory data user number, and then in the case of 0, the owner user, that's just a symlink to data, and everything else is actually a directory, and it's owned by the user's UID. So this kind of helps to understand why they've gotten rid of these mode world readable and mode world writable flags in API level 17, because this is part of your file system namespace. You can make reference to these files, right? They're mounted on the file system, they're available. So if they're other readable and other writable, you're going to be able to make cross-user accesses. And so if you've got shared preferences, you're going to be able to read those or write those, or any other kind of data that's potentially stored with those bad old settings. And it's not gone, it's just deprecated. All right. So applications are obviously going to see their own data without changing their code, and the isolation is not that namespace-based isolation. It's just sort of normal Unix file system. So the Unix permissions are still your only enforcement point. So here's a spot in data Dalvik cache directory that shows how that all group is used sometimes. So you can see how these things are all in group all A41, A0, A1, A2. And this is the DEX, so the compiled versions of the actual application binaries. So these are readable by every app, right? There's no, this one file system is still being shared. All the pages are going to be in memory only once, no matter how many times they get used. And app private stuff continues on its own hopeless path of pretending that publicly distributed code could be secret, firing away with the cannonball of obscurity. But normal apps that don't do that sort of stuff are just going to be this nice simple layout and accessible to all. So that's for normal internal files, right? There's also the external file storage. And the external file storage, as I mentioned before, has been a historic problem for Android. This is like your SD card, and it's had this long history. There was the ability to add read and write access controls sort of slowly being put in there. Oh, yeah.
Is Google thinking about some API for maybe secure elements storage for those critical permission things, etc. For example, authorization of users. There is some other concept of security storage.
Yeah, good question. A lot of people ask for something kind of like what iOS has, which they have this keychain that allows them to have secrets that are stored on the device and backed by their hardware security, where only they know your secret key. And they do know your secret key. They keep a copy of it. And you can read about how the government sometimes unlocks phones with it and stuff on Ars Technica, and they're grumpy because it takes a couple of weeks to get it unlocked. So that's a very nice feature. And if you think about it, when you have a ton of different OEMs all trying to compete, it's a very hard thing to just do generally. It's super tied into the booting process. You need effaceable storage so you can actually destroy secrets. You need hardware encryption units and stuff that can store keys. So the attempts to do that I'm aware of so far are things like Google Wallet, right? Where there's in some devices, a special piece of, like a secure element, a special piece of hardened storage that can perform certain types of operations. And we've seen how well that's worked in practice so far. It's sort of been a mess. I don't understand how they could easily do something that would really be secure, given that they have to rely on tons of OEMs. And if they did something, I think it would be worse than doing nothing in a certain sense, because then all these guys would go around and screw it up. And you'd think that you were doing something that actually helped users, and you absolutely wouldn't be. So the way to solve that correctly is to escrow the keys on the servers, which is something you don't normally hear a security person say. But you can store a big, long, nice cryptographic strength key on a server, and when a user logs in, have them get that key. They store it only in memory, never write it to disk, and as long as they're online, they're able to access the data that they store.
But you know that their secure elements can be not also on the device or the SIM card, but also on the SD card. So there can be some secure elements that user can control and put their security that he's basing on. Put their own keys, and he's the master of the his.
Yeah, you can
treasures.
roll your own security stuff, and Apple's going to just give it to you right out of the box. And it's not. I mean, Apple stuff used to be fake, right?
If you will stick to the global platform protocol, no way.
Right. But you have to build it if you want it, I guess is what I'm saying. And so that's a lot to ask for users. Would you go buy this special SD card and this USB device or whatever? So yeah, it's a hard one to solve. This external storage has been a big problem. We've been slowly adding things like write protection to it. But even when you have like write protection, it is still sort of like you can write everything or you can write nothing, but you can always read everything. And in Jelly Bean, they're saying, oh, well, now maybe someday we'll have external read storage protection also, and it'll also be read all or nothing. So really tricky to make work well. Zygot actually, which is this root process that forks off everything on Android, it now has support for using Linux namespaces and actually replacing the SD cards with their own independent mounts on a per user basis. So when you have external storage now, it's not shared between the users. And this was the first thing I expected to see. Like when I first heard about multi-user mode, I thought, yeah, this is going to be a big issue because you're going to have all these people sharing the same SD card. But no, they've got these namespaces. And so even though the Unix file permissions are bad, right, you're still isolated by the use of these namespaces. So you actually see different mounts. If you look in the procfs for the PIDs, you're going to see different mounts, which is kind of cool. So they've got they've got a good way to kind of isolate this on a per user basis. And that's totally transparent to users and apps, although if someone ever ships a tablet with an SD card that pops out, it might confuse the hell out of people. So I don't know how that's going to work. All right. So I'm going to have to go faster. Let's see. So trusting the owner. So owners own devices, and you have to trust them. And if you think that that's not the case, just revisit your assumptions. There's a couple of places in Android where this gets tricky. Like in settings secure, there's this little spot where settings are kept that are secure settings, and secure system settings can't be changed programmatically. The way that you do it is you go into a UI that's a system trusted UI, and the users explicitly modify them through the UI. And that makes it so that you can have settings that, like turning on USB debugging, that can't be just done by some bad app that you downloaded. This kind of messes with that model, right? You're going to have to extend the system. You're going to have to change all those system services so that now they know to trust only the owner and not the guest. Right? So what's that come down to? Well, on an owner's device, obviously they can activate USB. Like they can turn on USB debugging and they can go in. And then they can go and they can hook up a shell and they can do something like running this command, the content query URI, and pull out the context. And they can just specify another user ID. And they can pull out some other user's contacts, right? So, because that thing has all of those permissions I mentioned. It can interact across users. It can sort of see what's going on. So if you confuse yourself enough into thinking that users can't trust owners, you can play with ADB and convince yourself back to the right way of thinking. But it should be intuitively obvious. But nonetheless, very few people seem to get this at first. I didn't get it at first. So. The other way around is not supposed to be true. So on the first version of Jelly Bean on 4.2.1, this unpatched version, the non-owners could enable USB debugging. So if you went in through the UI, it wouldn't show you the UI. They'd block the UI. But if you went in with a terminal, and you just, not an ADB shell, but just a normal terminal app, right? And you just ran this AM start application development settings, you bring up the UI, and then you can turn on USB debugging. And that thing has the right to make that change in the system. And that would then let you do things that were nasty, like turning on debugging, setting a backup password when they don't have a backup password, so they can't change it because they don't know what it is, right? It'd be a big hassle. So that's been fixed in the 4.2.2 release. That's part of making it so that the system doesn't want guests to be trusted. But that issue sort of nicely illustrates what you need to do when you're making a system service. You have to change it so that you don't allow users who aren't owners to modify anything that's important and cross-user. So you can get, you can see where they tweak this in their development settings code. They just blocked it in the UI. And normally, when you hear they just blocked it in the UI as a security person, you're supposed to go, ah, right? But that's actually potentially the right way to do it here, because what you're trying to do is you're trying to have this privileged system API that knows when it's being called by someone it trusts, and it only lets the trusted person do that. The other thing they did in order to fix this independently and strongly was they also changed it so that in 4.2.2, and not in 4.2.1, now when an Android device gets plugged in with ADB, it pops up a dialog and asks, right? And so if it's a lost device, maybe that doesn't fix this independently because they would already be through that UI, but it does fix it for the lost device case, right, where you pick it up. So, but anyway, it's, let's see. Also, back in an earlier version of Android in like maybe level 10, so if you look around, you'll find a bunch of devices that run really old versions of Android, like tablets and e-readers and stuff. And some of those actually leave ADB on by default. And that's a really bad idea, right? That can obviously, there's no need to type in your passcode for the screen if you just have ADB running and you're running old Android. If you're running new Android, then it's going to, give you at least a chance to require that screensaver. But if you're running like version 2.3 of Android, that would be API level 10, right, which is one of the most popular versions. That thing is like a lot of major releases out of date now. And so it's not even the most recent version that was released in 2011. It doesn't give you a ton of security. All right, so here's an example of how one of the system services was changed. This system service is a clipboard service. It was a fun service to look at because the code used to be like small enough that you could almost write it on your hand. It was my go-to service for explaining how Android system services worked, because all it did was get a string and return it, and now it's much more complicated. But the gist of it is just this per-user clipboard, right? They just changed it so that when you get a clipboard now, it's not the clipboard, it's a per-user clipboard, and they're indexing them by UID, and, or not by user UID, but by user ID, which they changed to calling user handle in the documentation somewhere in the middle of the code, and it didn't get propagated into this name here, but that is what it's called most other places. There's other services they had to change, obviously, like the location manager service has all these multi-user mode changes to do things like make your location preferences specific on a per-user basis. All right, so another weird thing about this is Wi-Fi and Bluetooth. And, networking configuration has to be shared on the device. It's really important you have access to your network when you turn it on. Bluetooth was a little bit more surprising for me. Bluetooth can be really scary, and there's a lot of security stuff they're doing to make Bluetooth stronger, which I certainly don't have time to go into. Just as a neat example, I paired a pair of Bluetooth speakers to my device and turned it on and switched between users and saw that, okay, it's willing to kind of trust speakers because I guess that's considered low risk or whatever. But when you pair a keyboard up, if as a low rights user you pair up a keyboard, the owner knows about the keyboard, but it doesn't just automatically start running it and allowing it to control the device. So there's some isolation there. But it's exactly the kind of thing that you have to worry about if you're writing system services or components as a MDM or platform manufacturer, someone writing privileged code on devices that now have to support this multi-user stuff. All right. There's also, I kind of talked about this a smidge before, but there's some settings changes. Anything that's device-wide now can't be programmatically changed, and it can only be changed in the UI by the user. And that's kind of frustrating for some people. It's going to break a bunch of stuff. But it'll help us be safe from having low rights users turn on our USB debugging. All right. So I think I've got a minute or two for questions.
Questions? Okay. Any questions? Yes? No? No. Okay, thank you very much for the presentation.